Olá, uma boa tarde a todos. Vamos iniciar agora a apresentação, a palestra do professor convidado, o professor Aldo Sotolitio, da Universidade de Bordeaux. Queria agradecer a presença de toda a audiência aqui, na sala 4120 da Pós-graduação em Oceanografia, da Faculdade de Oceanografia da Uerj, onde nós estamos tendo essa apresentação, e agradecer os professores que estão aqui presentes também, e principalmente o nosso palestrante, professor Aldo Sotolitio, da Universidade de Bordeaux. O professor Aldo, ele está aqui como parte de um projeto internacional da Uerj, com o Centro Nacional de Pesquisa francês, o CNRS, dentro de um projeto chamado VELITRO, e tem aqui, veio para participar também de uma coleta de dados conosco, na região do cultivo marinho da Ilha Grande, onde a Uerj tem um projeto já de longa data, e tudo isso como parte desse projeto internacional, que envolve alunos, envolve tanto professores daqui da Uerj, quanto professores da Universidade de Bordeaux e de outros centros de pesquisa na França. Tá? Então, espero que todos aproveitem. Well, thank you all very much for coming on. Today we're going to have Professor Aldo Sotolitio from University of Bordeaux giving a talk entitled Water, Sediment, and Oxygen Dynamics in a Microtidal Turbidity Estuary under Multiple Pressure. Aldo, once again, thank you very much.
Okay. Thank you, Alex. Good afternoon, everybody. Well, thank you again for the invitation, and I have a really exciting week here, sampling and discovering the Ilha Grande and this specific area under study by you, Anna, and others. So we will move to France and to the estuary. I will present a kind of overview of some research during the last years, in collaboration with many people, and especially these colleagues who are colleagues or former postdocs or former PhD students. So yeah, water, sediment, and oxygen dynamics. This is what I work on. I am a sedimentologist, and I moved to physics during my PhD. So I know a little about sediments, sediment dynamics, and also about some physical oceanography, but specifically estuary physical oceanography. So what is the motivation of our studies that I will show you and synthesize here is that European urbanized estuaries in the last decades, or even in the last century, have been extensively deepened and narrowed, and this is something that Anne Winterberg in the Netherlands investigated deeply with a kind of synthesis of many European estuaries. These estuaries are recognized to have evolved to kind of hyperturbid conditions, which is that there's much more suspended sediment in the water than in the past. And this is under low feedback between mud trapping and tidal amplification, and this is a kind of very interesting mechanism that highly controls most of the dynamics and transformation in estuary. So our motivation is to try to understand changes in morphology, because morphology has multiple functions. I am in a laboratory in science which is multidisciplinary. There is not only physics, there is a lot of biochemistry, a lot of ecology, a lot of chemistry, and they are also they are all concerned by the morphology of the estuary, and also some partners are of course concerned with that because of the accessibility for navigation, because of fisheries, of course, and because of tourism. No, this is no. Yes. So modern. This figure comes from Winterberg synthesis. That's just two examples of estuaries, European estuaries, the Ems in the Netherlands, where you can see that along the channel, along the axis of the channel from the mouth to Papenburg here, 60 kilometers, the tide amplified between the 30s in the 20th century and 2005. So the high water and the low water now are more amplitude than in the past, due to deep deepening in this estuary. And among the French estuaries, the Loire is a very good example of the similar mechanism, because in the Loire there was big deepening works up to Nantes, the city of Nantes, here 60 kilometers upstream, and now the tide is much more high, much more high tidal range than in the past, and it propagates further upstream than in the past. So this is something that winter were generalized, and the behavior, the lesson of this is that because of too big ships and the need for navigation, there were too much deepening and narrowing in these estuaries. So the deepening and narrowing led to tidal amplification, and then there is a kind of loop, because tidal amplification, of course, means increasing in the tidal asymmetry. Tidal asymmetry with shorter floats means pumping of mud more upstream, more pumping of mud, and more pumping of mud means more mud deposition, so reduction in hydraulic drive, and this favors tidal amplification, so the loops is closed like that. So in the Gironde estuary, actually, the Gironde estuary was not part of winter wells study, simply because the data was not easily available at that time. So we started to investigate specifically this site in the frame of many projects. So the Gironde estuary is here in the southwest of France. Bordeaux, where it comes, is here, and it is the largest estuary of the East Atlantic coast. It is macrotidal, of course, as all this coast. It is convergent. That means that the tidal range at the mouth, when it's about 5 meters, increases upstream, and in Bordeaux, it's about 6 meters and even more than 6 meters upstream. It's a quite shallow, as many estuaries, quite shallow system, because the average is only of 6 meters, except a very narrow navigation channel here, which is about 12 meters depth. That is very narrow and artificially, of course, it's well mixed in terms of salinity gradients. So it's not an estuary known for its density stratification. Actually, fresh and salt water mix pretty well. And one of the main features of the estuary is estuary turbidity maximum, ETN, which is very highly concentrated in this estuary. You will see that waters are very, very highly turbid here. And one of the phenomena that we observed in the last years, decades, which motivated this investigation too, is that in the Garonne we start to see frequent summer hypoxia, the drastic decrease of oxygen in the summer. So the question, of course, what is the recent evolution, and what can we expect in the future? One of the recent aims to study estuaries is the fact that the risk of flooding are increasing. And this is a video of the water from in Bordeaux downtown. So this bridge actually is here now. This picture is too old. The bridge is here, and what you see here is a video taken from this area. And this flooding is only because it's high tide on springtime. It's not because of the river. It's because of the tidal range, because of the high tide of the tidal range. So we have in presence of a kind of periodical flooding, and of course all the forecasts say that there is something that will increase in the future. And these two pictures are other pictures. This is in the upstream river of the Garonne, and this is in the downstream to show you that there is a lot of mud. That's the main message of this slide. And Bordeaux downtown shows some brown green waters because of the mud of the permanent turbidity maximum there. So I will show you three kind of studies. One of them, the first is a study with data, real data, to see how the estuary evolved in time. It was not easy to collect this data, really, and even if we are in science and we are supposed to get easily a lot of data from the government or from public institutions, it was really not easy at all. So we are still digitizing, scanning some all on maps, and this is what we are trying to collect right now. Bathymetry of from the 50s, every 10 years more or less. Of course, since 1994, the bathymetry is digital. We don't need to scan, but for the all maps, all of them need to be scanned. Tidal records are pretty old, but again, they are not so easily available. So we're starting to digitize the water level records. So we have some of them. So we are completing data for some specific decades to how we face the bathymetry records. And maybe the easiest parameter is the river discharge, because this is something easily available in the internet. So we are collecting. We have studied part of the data, and some other part is still under collection. So this is one of the methods. The other one is numerical modeling, and what I show you here is a three-dimensional numerical modeling simulating hydrodynamics and sediment transport, fine sediment transport, to reproduce the estuary turbidity maximum, and in which we couple a biochemistry model to simulate also the biochemical processes and the summary process. So what you will see here is a simulation of one typical year. We start in January when the river flow is pretty high, and we finish at the end of the summer. So when we move from winter to summer, of course, there will be kind of high river flow first, and then the decrease up to the dry season. And at the dry season, you will see that the ETM will move from downstream to the upstream estuary. So you can see first this part here. So you will see that first the ETM is downstream, and then we start to shift upstream because of the tidal asymmetry. So this is the main mechanism in these macrotidal estuaries to trap mud in the estuary. So now we see the ATM here in the Garonne tidal rift, and on the right you will see that dissolved oxygen is also evolving, and I will show you this. So in winter, of course, the water is well oxygenized, so 100% of saturation of oxygen. But while we move to the summer and to the dry season, the temperature increases, of course. So the first factor of this is the increase of temperature. But also, the wastewater coming from Bordeaux town will be trapped in this area and be trapped in the ETM. So because of the estuary circulation, the mud trapping, there will be a decrease of oxygen in this area, and values are quite low. And well, one of the achievements here of this work was to reproduce this phenomenon, to play with some scenarios that will be shown. I will show you later. And the third kind of tool we have here is another numerical model, but it's an idealized with average two-dimensional model. So it's not a three-dimensional model, it's a 2D model as it's idealized. So we change the geometry of the estuary to something more simplified, and we only studied the upper part of the cable. Which one? I see it's still in my screen here, but yes, the connection may be. Put it off and then.
Para entender. Aí.
Well, stress. Sorry. Sorry. It will happen in 10 minutes, I guess. So this is an idealized model of only of the river portion. Okay, it's just to investigate what happens specifically in this high and this in the river portion because precisely Bordeaux is a critical area due to the low oxygen. What is the calibration of the idealized model? I don't need to go long. I prefer to move to some results. So one of the preliminary results with the morphology, because we don't compare all the bathymetry maps yet, is that there was some differential trend in the Gironde solid, in the lower Gironde solid here, between the 50s and the 2000s. And what you can see here is the differential. It's not easy to. There is nothing to say with this difference. You know, that there is erosion areas and deposition areas, but it's kind of unclear. Right? However, when we compare the cross section, the rate of cross section, we can see that downstream Bordeaux is here 0 kilometer, and this is the mouth. There is clearly a period in the 60s. In the 60s, where there was a trend for sedimentation in the lower portion of the estuary and erosion in the upper area of the estuary. And in the 80s, there was a clear shift. The side and the middle of the estuary was a kind of axis node, and the trend inversed, and the erosion started in the lower area, and high deposition sedimentation in the upper area. And this is primarily due, of course, to the upstream shift of siltation, and we can infer that this is due to the shift of the ETM. When we look to the river flow, we can confirm that this is probably the main reason, because when we analyze the river flow data, we can see that the low discharge periods have increased with times in the 60s. And these two graphs are kind of indicators taken from the river discharge measured in the Garonne and the other river here close to the Garonne. And both show that there is an increase of the low discharge period, and also there is a decrease of the water volume during high discharge period. So both contribute to a kind of persistence of the ETM and the increase of concentration in the upper estuary. So why the river flow decreased? This is a matter of conflicts in the region, because of course some part of the scientists say that climate is the main reason, but there is a lot of use of the water for agriculture, for example, a lot of pumping of water in the watershed, and so some part of the population is in conflict with this reason, because they are accused to be part of the problem. This is another kind of result from the data, from the real data. So my colleague here, my former PhD student, and now my colleague Isabelle Chayon, she studied the tidal charts, the tidal records in these 3 stations in the Garonne tidal river, so we're in the upper estuary, the tidal river, and she showed show that there is an increase in the tidal range from the 50s, and there was a kind of shift in after the 90s. And we can see that this happened in all the stations, in the Marquis, in Bordeaux, and in Cadillac. So the average tidal range has increased of about 50 centimeters and more than 1 meter here in Cadillac. So there is a more upstream propagation of the tide now than in the past. And more propagation, amplification, and increased asymmetry. So the asymmetry, as you know, as I told you, is one of the mechanisms responsible for the pumping of water. So why we observe this? It's not very clear, but it seems that the main reason is that there were some gravel extractions in the tidal river upstream Bordeaux in the 70s, in the 60s, in the 70s. And I say it's unclear because unfortunately we don't have any data about that. We don't have bathymetry maps charts, and there is some pictures taken during that period, and now that we can compare the morphology only with the ice, but it's not very clear. But this is so far the main hypothesis that this is due to gravel extraction in the data. In Winterwerth conceptual loop, there was the effect of hydraulic drag. So we try to check with the data if this is something that we can check, that we can observe in our area. And this is all these dots are on one tidal cycle, the tidal range in the mouse compared to the tidal range in Bordeaux. So it's a kind of tidal amplification plot. So in general, of course, the tidal amplification decreases with the tidal range. So in spring tides, the tidal range in Bordeaux is pretty close to the tidal range in the mouse, and on mid tide, the tidal range in Bordeaux is much higher than that in the mouth. Because there is more convergence actually in mid tides than in spring tides. So we have always this trend. Now, if we compare the years, the dry years, and the wet years, there is something curious, because if we separe the periods, the tides before the ETM shift upstream and after the ETM shift, in dry years, you can see that there is no difference, because the ETM is all over the year upstream. So there is mud all over the year. But when we look at the wet years, wet means that there was a period when the ETM was in the lower estuary during hydroflow, and then at the dry season, the ETM shifted upstream. So there is a difference before and after ETM shift, and we can see that in the amplification, the tidal amplifications is much higher after the ETM shift, which means that when the tidal river is muddy, is in dry season, there is a better, easier tidal propagation, and when we are in a wet period, the bed of the tidal river becomes more sandy, and the amplification is lower. So this is I think that this is 2 different years, 53 to 05, but the trend is the same, as you can see, for dry and for wet years, even if we are in the past or in the present. So it seems that there is a role of the hydraulic drag. Yeah. Now I move to the result from the numerical modeling, the idealized 2D numerical model. So this is a way to try to separate the respective effect of these different mechanisms. So what we can see first here is the result of the simulation of the concentration, the suspended sediment concentration along the tidal river, the Garonne tidal river. So Bordeaux is here, Bordeaux, this is the confluence, and this is upstream. Depending on the river flow, of course, for the lower river flow, the ETN move upstream. For the higher river flow, for the ETN is shifted downstream. And then we converted this information into this. So what you see here is the same axis here of the channel, Bordeaux and upstream. But here you have the river flow. So for low river flow, you have the ETN more upstream, of course, and for higher river flow, the ETN is pushed downstream, which is totally normal. Now, the interesting thing here is that we use this model, validated model, to compare the situations in the present and a situation in the past. So, to represent the past, we change the bathymetry, of course. We needed to use a new bathymetry, but we use the same river flow values. And what you can see is that if we compare the 1214 with the 1953, there is a turbidity maximum better dispersed in 1953 and moving a little downstream than in 2014. There is some differences, but it's not very clear at this in this figure. It's more clear if we play with the different mechanisms in the model, making some tests and comparing what is in and what is out. So what you can see here is the axis of the tidal river again, Bordeaux upstream. This is the time. This is year 53. This is year 2014. So you understand that we simulated these years because we have data for this year. There is no other reason. We have some data, bathymetry, tides, and river flow. So this is the reference scenario, meaning that when we compare the past situation and the present situation, there is a shift of the limit of the ETN upstream. And these three scenarios correspond to scenarios in which we remove something. So in this scenario here, we remove the changes of the tide here at the entrance of the tidal. So we assume that changes of the tide in the confluence here are due to changes in the morphology in the lower Gironde district. So we can see that if we use the same tidal range in year 53 and in year 1214, there is no change in the turbidity maximum. The ETM does not shift upstream in this case. So that means that we need to have some changes in the lower estuary to explain the shift of the turbidity maximum. If we remove the deepening by gravel extraction, which means that we use the same bathymetry, you can see that again change are less significant. It's isn't clear. So that means that we need somewhere some deepening, some changes in the morphology of the upper Garonne to explain the shift of the turbidity maximum. And the last test here is the test of the changes in mud roughness. So here we remove the changes of roughness, and again we can see that if we remove them, there is less gradient, less difference between the different years. So we need for but this is less significant than morphology and deepening. But we need for this mechanism to explain to follow the complete. So if we go back to the winter wave concept, we wonder if this applied to the Gironde estuary. Actually, not exactly, because in the Gironde estuary, the deepening and the narrowing happen specifically in the tidal river, the upstream part of it. So the gravel extraction is the cause of this deepening and narrowing, but in the upper river, and rather deepening than narrowing. And another important factor here is the decrease of river discharge. This was not considered by Winterberg, but in our case is a really important factor that explains the shift of the mud upstream and also the tidal amplification, because the river discharge is something that can damp the tidal range, but if it reduces the tidal amplifies easily. And another factor for tidal amplification are the changes in the lower estuary. So this work is in progress for the lower estuary. For the upper estuary, things seem to be quite clear. So now I will show you some results from the three-dimensional modeling to show you some future evolution. This is not a prediction, of course, but just we played with the model changing the mean level at the sea to see what happens if we change just the water level at the mouth. And what we can see is that this is the salinity field along the Gironde estuary. This is the mouth, and this is near Bordeaux in the present time. So the reference simulation, and this is the same situation, but if we increase the sea level rise of 1 meter, which is a lot, right? But for lower increase, changes are not really significant, at least in the geometry. So what we can see here is that there is at the bottom and at the surface a global increase on salinity. If we have an increase of the water level and an increase of the stratification, specifically in the lower estuary. In the upper estuary, there is not too much difference. The difference is mainly in the lower estuary, where the salinities are high. What is the effect on tidal currents and SPM if the sea level increase of 1 meter? So quickly, you can see that this is the lower estuary, this is the upper estuary, this is the tidal level, this is the tide, this is the tide, and this is tidal current. So the only change what we can notice here is tidal currents, and specifically during flood. On the lower estuary, there is no changes. Nothing happens if the sea level rises from 1 meter. However, in the upper estuary, nothing happens in ebb. However, we have accelerated flood. So because we have an accelerated flood, we can expect that we have more resuspension and more suspended sediment concentration in the upper estuary. So the effects seem to be limited to the upper. So those were results only about the ETMs and only playing with the sea level rise. There were no other effects. So it's a very limited exercise, of course, but it's a kind of theoretical thing. And just to finish here, I would like to show you results about the modeling of the dissolved oxygen, because with the model I showed you first, simulating hypoxia, we try to explore scenarios, future scenarios, hypothetical scenarios. So what you see here is the oxygen saturation in the near Bordeaux, in the Garonne River, during 1 year, okay, from January to October. As I show you, it's high during winter and it decreases in the summer. Okay, and this is the hypoxia moment. So what we can see is that if we increase the temperature, the air and water temperature of 1 degree, but no surprise, the oxygen will decrease a little bit in summer. but not too much actually. It's about the saturation will decrease about 10, maybe 10%. And another effect that we added in the model is the effect of the decrease of the population of Bordeaux, meaning that if there is an increase of the population of Bordeaux, there will be more release of organic matter in the water, in the water of the tidal river. So it will increase this rate of organic matter. There will be a decrease of dissolved oxygen, but of about only I don't know, that's something like less than 5%. So the critical hypoxia is happening now. In the future, we don't know how it will be, but increase of temperature and increase of population seems to be not critical, not as drastic as we thought. However, there is a limit of 2 milligrams per liter, which is a kind of limit to not go below. And if because of the increase in temperature, we are sure that we will be below the limit sometimes during the summer. So this is something critical. So this is a simulation just to view what happened in one single point in time. But we also explore scenarios at the scale of 50, 2050, and 21, 100. So a couple of 60 and 70 years, more or less. And we play here with the decrease of the rivers. So what you can see here is again the same reference year from January to October. This is the evolution of the temperature. So temperature is high. Sorry, this is not the year. This is only the summer. It's June to October. So we are already in summer. So the temperature is high already. And what you can see is in the situation of 2100, the temperature is higher of about 3 degrees than in this scenario. This scenario is 2 degrees higher than the present day. So these warmer waters, of course, will drive a higher decrease of dissolved oxygen. And what you can see here is that in this scenario, with a lower river discharge, the increase of the population and increase of sea level, and 2 degrees warmer, there will be hypoxia for about 20 kilometers along the channel. So this is something that can have an extension along the Garonne River. This line is Bordeaux here. You can see that the hypoxia is centered in Bordeaux, that can be upstream and downstream, and it will happen most of the time during spring tides. Spring tides is here when we have a strong turbidity maximum because of high resuspension. So high resuspension means a lot of pumping of oxygen because a lot of material goes below. And in this worst scenario, you can see that we can have an hypoxia permanent hypoxia during all the summer, during spring and during mid times. So this is the worst scenario that we are we have in mind with the development of a kind of dead zone and companies. So I go to the conclusions because I show many different kind of reasons, and as a synthesis, during the last 60 years, the Gironde has experienced changes on the morphology, but not very significant. However, the cross section showed the shift of accretion in the upstream portion due to the persistence of the ETM upstream. There is an increase of the tidal range specifically in the tidal river, and it is due to change of the morphology after the year system. And this favored the ATM persistence in the recent years, with effect on water drag and a loop with tidal amplification. But something that wasn't considered in other studies is that here the river flow is a very important factor, because in the feedback loop it plays a role on the tidal amplification and on the shift of the TM. The tidal rivers, even if they are far from the lower from the sea, are very sensitive to sea level rise, and this is something that managers don't know. Scientists know that, but not managers. So this is an important message to them. And dissolved oxygen is sensitive to physical changes, of course, with possible future permanent extended hypoxia. In these simulations, what we missed is to account for morphodynamics. So this is something that we need to do in the next future. Thank you.
Thank you very much, Aldo. Now we are open for questions. Anyone? Se alguém não se sentir à vontade de falar inglês, pode fazer a pergunta em português.
You can translate the question.
Exatamente, tá? Bom, boa. Enquanto vocês pensam se tem uma pergunta, eu vou pedir, abrir também para as questões aqui, os professores presentes, fiquem à vontade.
I have a question. You show us about the data that from tidal stations. There's some years that you have the data, but
not digitized yet, not ready to be analyzed. We collect the data, but we didn't finish to digitize the complete year.
Something more.
Right. Yeah, sure. We have. I was very optimistic when I showed this this chart, because actually we don't have. Well, we have the tidal records you can see here, 53, 71, and the 1000 because it's modern data. But we don't have them all along the estuary. We have only the 3 stations upstream. So what we need to do is to collect the tidal records in the downstream, in the lower estuary. This is what we are missing now. And we need that to check if there were changes on the tidal amplification in the lower estuary in this period, because the only evidence we have is in the upper river around Bordeaux, but we don't have data downstream. But the model shows that we need, to have the shift of the observer shift of the ETN. It needs to happen that the tide there was some tidal amplification in the downstream estuary, but we don't have the data yet.
I have one question about the ETN. Yeah, because you told me that it's more influenced by the river discharge. Yeah? But with the modeling that you have there, that you show, it's compare also how it is raining in the Tomis Basin and also the increase in the tidal level, for example, because of the sea level rise. How can you compare it? Because I can see just the ETN changing its position, but I don't know how you can evaluate it when you have the both influence at the same time.
And this kind of simulation, you mean?
No, the model in general.
In general?
Yeah.
Well, in general, we only prescribe to set the river flow, a flow of water, a discharge in the upstream unit. So we don't care too much about rain. We didn't pay attention to the rain. We only prescribe the river discharge. We can, I didn't show you the simulation, but we simulated different scenarios with a constant river flow, different tides, and changing river flow and constant tide. So this is a way to explore the relative importance of river flow and ETM. We did this with this model, with this analytical model. The paper is already published, and there are many results that I didn't show here, but we did this kind of analysis that you are asking about. And what I can say is that we need the tide to form an ETM. If there is no tide, there is no ETM. And once the ETM is there, the river flow is a kind of factor to modulate the position, the average position, average over many tidal cycles, because every tidal cycle is shifting the ETM, but the average position can be associated, can be linked to the average river flow. So it's a kind of secondary mechanism, but it is very important in the long term, because at the scale of years, the fluvial drainage regime is what will control the position of the ETM. At least in the models, this is what we have seen so far. And you talk about rain. Well, we cannot consider rain. We just know that in the watershed it's raining, so the flow is high. But we do not put rain in the model or in the estuary. We just put fresh water coming from the upstream limit of the
river. It's just because I thought in the same context, yes, the rain and the velocity between each page are at the same time.
Right.
And in comparison, how it works the model, because you're going to have, for example, these 100 years, and it was up to 2,100. Yeah, I don't know.
Yeah, but we did not simulate it continuously 100 years. We just one single year. But I mean, it's an overestimation of what it means. When I put the years, it's like could be like what the GIEC says about temperature and sea level, but it does not represent the year after a simulation a long time. Just one year with this temperature, with this sea level, which represents something future, but, very schematic.
About the values of the river discharge, I didn't get that from the beginning. Are they re-measured? So you have a time series of this data in the upper estuary, or is it just like you just set up a value for the model based on something?
No. They are measured. They are measured. They are really measured at the upper limit of the two rivers.
Okay.
Here and here, and every day, every hour. Actually, this is the best database we have in internet. We can find the discharge, and even in the past, the database from 1955, after the Second World War anyway, but since the 50s, there is a continuous database on the daily discharge. And not only in those rivers, in many rivers in France. This is something that works really well. So we can prescribe the realistic river discharge, but in the model we can also use schematic constant high or unrealistic river discharge, as we like.
Yeah, this is one of our main challenges here, because we really like river discharge measurements, especially like long-term ones.
Yeah, I know.
Very complicated, yeah. But anyway, it's a very nice data. In that scenario that you were explaining us, where you increase the sea level in 1 meter, so the stratification in the lower estuaries gets higher.
Yeah.
Do you, in that scenario for the lower estuary, do you have I don't know if you talked about the salinity penetration. I mean, do you have a gravitational circulation, and how much the salinity goes up in that scenario?
the upper limit of the salinity.
Okay.
In the case of the sea level rise, the difference is you see that the visual line 4 moves of about 5 kilometers upstream.
Okay.
This is what the model says, and this is the increase of salinity at the bottom and at the surface. And this is the salinity difference. It's not really an indicator of stratification, but it's a kind of a difference. So the difference, the present day difference is this. Oops. I'm sorry, I'm very bad with this these new tools for me. With the sea level rise, you can see that there is an increase of the difference. So there is more. You can expect more gravitational circulation.
Right.
However, this is very interesting, but this is not in the critical area of the trapping of ETM and hypoxia. So we would like to study these two, but those who pay for our research, they are interested in the area, are concerned about what happened in the upstream river around Bordeaux. Okay. But we are looking at the whole system.
Okay, so that was pretty much a 5 kilometer.
Yeah. Well, this is what the simulation said. But of course, the sea level will not increase of 1 meter in one night, and the morphology will change. Mm-hmm. So the tide will change. Okay, we not account for that. So we're not sure at all that it will be really a 5 kilometer shift. It would be maybe more.
Yeah.
And with that same river discharge, which is not sure at all.
Also may change.
Eu tenho uma questão para ele.
Ok.
Como a gente está na década do oceano e nós estamos nessa vibe de compartilhar toda a ciência produzida com a sociedade, qual é o impacto direto que todas essas mudanças podem ter na vida das pessoas que moram nessa região?
Professor Vanessa is asking that since we are in the ocean decade, the United Nations has established, so how do you evaluate that, how these changes that you are showing there, like for in this future perspective, they can change people's life in Bordeaux, in the area around the Giron estuary?
Well, the more drastic change is the one that I didn't show, I didn't talk about, which is flooding, which is the risk of flooding. Because we're just starting to work on that. It was not a research topic so far because the government service thought that everything was under control, the modeling were running well, but now we're looking at there are some periodic flooding, mm-hmm. and storms are increasing in an unexpected way, with some surges. Yeah. Oxygen is something that few people care about. Honestly and sadly, this is like it is because oxygen only is a concern for fisheries, and the population working in fisheries in Bordeaux is very low. There are few people working on that. It's not a major activity. Of course, wine is a big. Wine and tourism are the two big activities, and those who live from the fisheries are very few people. So it's only a matter to be concerned by the health of the system. But in terms of how people will be impacted, Bordeaux inhabitants, unfortunately, I think that we feel that the impact will be quite low. Maybe I think that we need to wait that the people of Bordeaux see the fish dead on the surface to say, wow, this is something wrong here. We need to do that. Because as long as it doesn't happen, we are only speculating, scaring people with some hypothetical stuff. In the Loire, another French story, it happened in the 90s that one summer all the migrating fishes were in the surface dead. People thought about kind of pollution, but it was only hypoxia, just the total suppression of oxygen. kill the fish. And after that, in the Loire, they started to activate some measures to improve the situation. In the Garonne, it's not happening. And my last comment is that your question, I like your question because, in my opinion, the people in Bordeaux, living in Bordeaux, don't feel close to the ocean. They feel that they live in a river. So everybody calls this the Garonne River, which is a river, but they don't care too much about the tide, about the salinity. They feel that the ocean is so far. We live in a river. And every time I try to talk about the estuary processes, many people in Bordeaux, at least, they feel like, oh, really, I didn't realize that. In the lower estuary, people know better how an estuary works. But in Bordeaux, most of people think that, yeah, we're in a freshwater river.
É a cegueira oceânica, né?
Quer que eu traduza? Tá.
Yeah, I'm sorry.
I'm sorry. No, long answer, Aldo. It's very nice. Ele disse que, a princípio, o primeiro impacto são as inundações.
Não, você quer traduzir o que eu falei para ele.
Professor Vanessa said that people are just blinded about they don't feel like they are close to the oceans, and they think that there's no connection when they are in the other side. So they just get blind about all these issues.
E deve ter impacto no turismo também.
And probably some impact on tourism activity as well.
Yeah. Well, Bordeaux is a place where there are very big ships, with cruise, ocean cruise coming into Bordeaux. So this is the only contact with the ocean that Bordeaux people have, but it's important for money, for economy. Yes, they care about it.
Então, basicamente, ele disse que o problema são as enchentes, né, primeiramente, e também interessante, quando eles começaram essa pesquisa, estava tudo bem, não era uma coisa que era nenhum problema local do governo, mas aí eles começaram a estudar, e agora estão vendo mais aumento da temperatura, começaram a ver alguns problemas de hipótese. Exatamente, a França tem tido um aumento de temperatura, uma tendência muito forte já nos últimos anos, né? Então, os invernos são mais quentes, os verões estão bem mais quentes. Então, todas essas coisas com o tempo vão começando a se conectar e aí, eventualmente, gerar problemas para uma população que até agora não tem essa percepção de algo ruim.
Eles acham que dependem mais do rio do que
Exatamente, eles não têm a conexão. Sorry, Josefa, you're going to
Short question. This reference baseline is average time or spring time, mid time?
These areas, it's high tide because this is the water source. For sure, is a high tide in the upstream estuary, in the upper estuary. Probably spring tide. Yeah. So, given the depth here, is a high tide, a spring tide. So that means that this is the upper limit of salinity that we can expect.
And was there an increase in suspect sediment contribution from the watershed in the last 2 decades? Have a shift of in the 70s, 80s, of course.
That's a very good question. I mean, we don't know if there were changes on the sediment fluxes from the river.
We don't have to measure it, even in the filter.
Yes. So we only know what's the effect in the estuary, the accumulation of mud, but we don't know what happens. No, and we need to connect with people working in the erosion of the watershed at the scale of all the watershed because they had some. Yeah.
I think his question was also related to runoff and things.
Okay.
Runoff,
yeah.
Really set not only water but sediment. No,
yeah, this is something that we should do in the future.
Yeah, we also have this.
Well, really the land and the estuary is
because we have increased
challenge.
Probably wine yards. No?
Oh yeah.
So probably,
yeah.
It's taking more sediment to destroy, but it's just like because.
Well, the vineyards are suffering now. I mean, guys, there are less vineyards than in the past.
Yeah.
Maybe you heard about that?
No.
Well, French are drinking less than in the past. They are becoming healthy. I don't know. They drink less. They drink less.
In general.
And the Bordeaux wine is not the best seller in the world. You know, there is a big competition with US, with the Italian, South American wines. So the Bordeaux wine is not the best. The number one in sales. I mean, sales. To me, is the best. But even after
We
the
need
chili
to
and
take
wine.
samples.
I could take samples. Yeah, it's good. Yeah.
Let's write that proposal.
Next time.
And we show the tidal amplification here, exists tidal bore here, yeah?
Yes, there is a tidal bore.
You have evidence of changes about tidal bore along the years or no?
No. We started to study the mechanism of formation of the tidal bore like 10 years ago. There was a big project conducted by some colleagues, and we measured for the first time. For decades, nothing was existing in the Garonne River about the tidal bore. And now we have our data set, but we don't have the time series in the law. We don't know. People, of course, when you ask people who live there, they say the tidal bore is higher than in the past. So we can believe them, but we don't have the data, the objective data. And it's likely that it is because of the amplification of the diet and because of the change on the morphology of the but we don't have the data. And this picture, so sorry to be too long, but you know that I like sediments, and this picture here is taking upstream Bordeaux, like 20-30 kilometers upstream Bordeaux. And this kind of tidal fact is just the formation of mud pushed by the tide and by the ETN, right? Yeah. So here we are in fresh water. It's not salt at all. And this is the area of the tide of the tidal bore. The tidal bore goes there. So the tidal bore is something that when it propagates, it erodes these areas and it's pushing mud more upstream. It doesn't. The tidal bore is only the first 10 minutes of the flood, right? It's quite short, but it erodes a lot and it pushes the mud upstream. So people notice that. It's another factor of shifting of mud upstream, and they say that this is due to the tidal bore. But we don't have measurements of that. We just believe people that who live there and who observe after decades. And it's a very nice spot. I don't know if you came, or if you're planning to travel to France, but it's a very nice spot for surfing.
Yeah.
This board in the Garonne, like the others in the world, right? In Brazil, but this one is quite. It's not huge, but it's big.
Any other questions? Pode perguntar em português. Carolina, alguma questão?
About the scarf, maybe.
About the scarf, she's gonna have many of yes. But she had a very good teacher.
Oh,
Well,
thank you for the questions and for listening.
okay. Well, let's thank our speaker again. Obrigado. Eu queria só faço esse tá. Áudio, vou só falar algumas coisinhas aqui. Pode ficar aí também. Yeah, picture will be good. Yeah, let's go for a picture. We're just gonna give a last message in Portuguese. Bom, obrigado a todos pela audiência. Agradecer também a CAPES, que é uma das financiadoras dessa parceria da Uerj com os pesquisadores franceses e também é responsável pela vinda do professor Aldo aqui nessa visita. Agradecer também aqui, novamente, a todos os professores presentes e aos alunos também. Muito obrigado, a audiência de vocês é o que tem de mais importante numa instituição como essa. E professora Vanessa, pela divulgação, né, no PRODIG, né, no nosso programa de divulgação da Faculdade de Oceanografia. E também a professora Gleice Moser, pela coordenação do subprojeto que permitiu a vinda do professor Aldo aqui. Tá? Um bom dia a todos e muito obrigado pela participação mais uma vez. Let's take